So before we get started, I'm going to ask you a bit of a question. I like audience participation, so I need you to give me a quick single clap if this pertains to you. So in the last 24 hours, have you used a feature on your phone that was designed for accessibility? Okay. What about in the last week? Okay, a few more. Maybe let me get a little more specific. Who here has used captions this week? Maybe TikToks on your commute home? Okay, a few more. How about dictation? So dictating a message instead of typing it. Single clap if you've used Siri, Alexa, or Google. How about listen to an audiobook? How about autocomplete recommendations? Nice. How about you got dark mode on? I was expecting that would be a little bit more prominent. How about you got your phone currently set to vibrate? Amazing. So something you might not have realized until now is that every single one of those was built as assistive technology first. So captions was originally for the deaf and hard of hearing viewers, and today 63% of UK's 18 to 29-year-olds watch them on TV. Dictation was built for people with motor disabilities. Today, about 2/3 of smartphone users use voice typing, at least occasionally. Voice assist came from screen reader speech synthesis, and 78% of European drivers have one in their car today. Audiobooks was originally called talking books, and they were designed for or made for blind veterans. And last year, 9.3 million Spaniards alone listened to at least one. Predictive text was also for motor disabilities to cut down on taps. And today, nearly half of all phone users use the suggestions. Dark mode was originally built for light sensitivity and low vision. And in 2024, it was reported that 82% of iOS 17 users had it enabled globally. 82%. And vibrate was so that deaf users could feel notifications that they couldn't hear. And today, 80% of users would prefer to have a phone with rich haptic feedback than one without. And so there's a name for this pattern, and it's called the curb cut effect. And so curb cuts are those little ramps at the corner of the sidewalks. They were famously fought for by wheelchair users in Berkeley in the 1970s, and today every stroller, every suitcase in every city uses them. Now, you might already be familiar with the concept of universal design, which is designing a product or an environment in which it works for as many people as possible without the need for any special adaptation. And the curb cut effect is actually a subset of this. The key difference being that the curb cut effect is usually accidental, but the outcome is the same. So the point here I'm really making is that when you build for the edge, you're actually building for everyone, intentional or not. So seeing as the European Accessibility Act went into play last summer, I'm going to assume for this presentation you do know the basics. And you've probably got most of that already in your apps, but I'm going to dive into something that you might have missed or maybe did some shortcuts on: accessibility in animations. And I know my next question I'm going to hear is, well, what about AI? AI can just do all that accessibility stuff for me. And AI has come a long way, even in the last 6 months, but 2 points still kind of stand. The first one is that accessibility is still an optional for AI. Think of all the tutorials and code that you've seen online where accessibility wasn't built in. That's because that's what it's being trained on, so it just doesn't necessarily populate it. You need to ask for it to get what you need, and if you don't know what you're asking for, you're not going to get what you need. So really, this talk is going to introduce you to hopefully something new, something to ask for, and hopefully how to test it. The second point is that the AI is primarily trained on the internet, and web accessibility is just a lot more prominent than React Native accessibility. So unless you're actually using an AI skill that's built for React Native for accessibility, you're likely going to get web patterns pulled in that just don't always work on React Native. So on that note, hello, I'm Britta. I am a developer at Shopify, and I've been working in React Native for about 5 years now, and mostly on Shopify's point of sale system. So around the same time that I started working in React Native, I also learned that I carry the gene linked to macular degeneration. And it's the same condition I watched affect my grandmother's central vision, similar to how you're seeing in the effect here. I don't have symptoms today, but I do know it's coming. And as life moves into digital spaces, I'm really in a unique position to be able to shape the world before I lose my vision. So that's why I'm here today, to help and empower you build a more accessible future with me. So I'm going to start with probably the most common setting you'd think of when you're thinking of animations and accessibility, reduced motion. So most people think of reduced motion as a support for vestibular disorders. So that's motion, when motion on a screen can make you, can cause nausea, vertigo, migraines, but that's really only part of the story. Reduced motion can also reduce distraction for people with ADHD. It can help limit motion, flashing, pulsing effects that might be unsafe for folks with photosensitive epilepsy. But it's also not just for permanent disabilities. People may need it during concussion recovery, post-viral illnesses, migration flare-ups, or pregnancy. During my first trimester, when nausea was at its worst, I had to turn it on. There's even some studies in Iowa State University that found that women were actually more likely to end VR sessions about twice as often as men, and reported sickness intensity of 40% higher. So, well, what does it actually do? Depends on the platform. When turning it on for an iOS device, zooms become crossfades, parallax experiences become static, and optional effects become opt-in. Overall, Apple's approach is what I would call a replace pattern. It doesn't mean that all animations are replaced, but it is meaningful swaps of zoom with motion with a gentler crossfade, replacing motion with meaning. Android, on the other hand, takes a very different approach. Their native setting isn't actually called reduce motion, it's called remove animations. And I think that tells you exactly what you need to know. It sets the animator duration scale to 0, and basically the philosophy is simply remove, with the general idea that to remove motion for speed. So where does that leave us React Native developers? So there's two ways to get reduced motion settings in a React Native app. The first, there is a Reanimated use reduced motion hook. It's synchronous and worklet compatible, but the catch is it actually only reads the value at app runtime, or startup time. So it doesn't update mid-session. And then there's always the direct from React Native's accessibility info. It's async, returns a promise, and has a reduced motion change listener for real-time updates. So if a user was going to toggle it on mid-session, you'll get that catch. For an app that I'm working on, Shopify's Point of Sale, we tend to have lots of users switching like on all the time, pinning in. And so we're not going to see an app relaunch between users. And so for us, it's important that we stick with the accessibility info. But you might need to consider other things. Now, I'm going to assume that you're probably using Reanimated if you're here. So every Reanimated function and layout function takes a reduced motion option, and there are 3 values: system, always, and never. System will adhere to the OS settings at launch, and it is the default. Always disables animations. Now this is for performance reasons, not for accessibility. And never disables animations, and this would be important for animations where the motion actually is the information. So think loaders or countdowns. But when reduced motion is enabled, the default settings are not always intuitive. Timing in spring will snap into place. Decay stays where it is. Delay will skip the wait time entirely. Repeat's also one to watch. If it's infinite or even reversal, it won't even start at all, and this could be very important for your loading indicators. And sequence can surprise you too if you have a child that's set to reduce motion never, because that one's still going to run, but the rest will snap into place. Now, I have just told you that the default tends to be to remove, but that's not always the best experience. I will encourage you to consider Apple's approach where it makes sense, and I tend to call this the swap, don't strip. So to show you what I mean, this is what the default experience would look like. The zoom animation is stripped out entirely, and with it, a lot of the delight, which is probably why you added animation in the first place. The swap version replaces zoom in with a gentler crossfade, so the users get a clear this opened transition, just without the zoom, depth, and motion that can cause discomfort. And here's the code. The changes all live in the entering and exiting animations, and in the swap version, notice that fade in and fade out both have a reduced motion .never. That's what tells Reanimated, even when reduced motion's on, to still play that easier transition, or that easier, gentler transition. And that's the whole pattern. Replace the zoom with a fade. So one last thing I do want to say on reduced motion is that Reanimated's reduced motion config, it looks like a component, but it is not scoped like one. It is actually a global get config setter. So if you wrap it around a single component or a single screen, it might look like it's scoped, but in fact, it will affect your entire app. This can be incredibly frustrating to debug when all of your animations have suddenly stopped working. So yeah, that may or may not be coming from experience. So this is probably a good time to remind you, reduced motion is really just one of the accessible features that you need to worry about. Then there's lots more. We've got color contrast, photosensitivity, cognitive load, transparency, voice control, scaling text, and screen readers. Each one of those could really be its own talk. Let me take a quick one off the list, which is color. Now, so for a button that is changing state, the animation might be fine, the motion might be gentle, and you might even have the right accessibility roles and states in there. But for a user who's colorblind, those visual states might look identical, making the state change effectively invisible. To test this, I tend to use grayscale filter, which I've just turned on now. So if the state only works in color, it's not going to work for everyone. And this is actually quite common. About 1 in 12 males are born with color blindness, and that is typically the red-green that is the most common. But what if you couldn't see the transition at all? For screen reader users with little to no vision, what matters isn't how it's being animated in, it's whether they know something's being animated in. So in this example, we have a button here that appears only after a specific action is performed. And a sighted user can see it pop in. But for a screen reader user, often you explore the page and kind of build a mental map before you, like when it's a new page, you'll build a mental map kind of before you start to navigate it. And if that button doesn't exist when that mental map is being explored, it's not going to be there, or you're not going to know about it. In this video I'm going to show in a second, you're going to kind of see someone explore the page and then add a promo code. I do like to give a warning. Screen reader users use their devices incredibly fast. I have slowed down the audio, but it will still be very, very fast for an untrained ear. So hopefully you'll be able to follow along.
Promo code, heading, checkout, subtotal, $42.50, total, $42.50, promo code, enter code, text field. Text field is editing, and CapEx. CapEx, numbers. 1, 1, 0, 0, return. Subtotal, $42.50.
So you can see they filled it in and then nothing. They weren't aware that the button appeared. It wasn't clear what the next steps were. And they would really need to re-explore that page in order to find the button, which can be very time-consuming depending on the amount of content that's on that screen. So to fix this, there's really more than one way to do it. And there are a couple strategies that you can pull from. So the first is that you can actually have that button in the tree from the start and just have it disabled. And that way, when the user is doing that initial exploration, you'd be able to find it right away. You could also announce the change, so use a live region or announce for accessibility to say, like, hey, something's changed. Or 3, you could move focus directly to it. Now, you might use one or a combination of these, depending on what your flow is. Each depends on your app and your flow. In this clip, I did try to use all three just to give examples. So you should know that the button is already in place at the time of exploration, that the announcement when the state change, and that there's a rerouting of focus once the discount's applied.
Promo code, heading, checkout, subtotal, $42.50, total, $42.50, promo code, enter code, text field, apply, dim, button. Enter code, text field. Type a code to enable it. Text field is editing. Cap C, Cap X. Cap X red. Apply button now available. Numbers. 1, 1, 0, 0. Return. Subtotal, $42.50. Total, promo code, X10, apply button. Discount, X10, minus $4.25. Promo code applied. New total, $38.25.
So the next common animation that I see that doesn't play well with screen readers is a swipe to delete. So let's see what lack of accessibility looks like for that.
Your shopping cart, heading. Spicy tuna roll, 1 times $12.80. Alert, spicy tuna roll. Quantity, 1 price, $12.80 each total, $12, okay, button. Spicy tuna roll, edamame, 2 times $5.50. Spicy tuna roll, 1 time edamame, 2 miso soup.
So why did this fail? Well, swipe motion's already being used by screen readers to navigate between elements, so it's not going to trigger that list item. Instead, we're going to need to add a list of actions that it can perform. And here's what that looks like, just 2 additional props. Accessibility actions defines the custom action exposed to VoiceOver and TalkBack, and the on-accessibility actions handles them. And just like the appearing animation or appearing elements that we saw earlier, swipe to delete is a change to UI. So it's the same strategies that apply here. So you can announce the item that's been deleted. You can so the user doesn't actually knows what's happening, or you could move the focus when the action has been applied. And yeah, here are the results.
Your shopping cart, heading. Spicy tuna roll, 1 for $12.80. Button. Double tap to view item details. Custom action. Alert. Spicy tuna roll quantity. Okay. Button. Okay. Your shopping cart. Your shopping. Spicy tuna roll. Delete. Spicy tuna roll removed from basket. Edamame. 2 for $11. Button. Delete. Edamame removed from basket. Miso soup. 1 for $4. Button.
One thing I should have mentioned there, I don't know if you noticed it, but the way that I actually accessed those custom actions was by either swiping up or swiping down, and then you still have to double tap to activate. And while we're on the topic of gestures, there's a few more that I'm going to bring up because I think they're really great to know, especially for animated areas or elements. The first is, or the first 2, I should say, are gestures that are connected to controlling accessible role adjustable. So think sliders, steppers, scrubbers, anything range-based. So even that jelly slider we saw so much of yesterday. Screen reader users usually interact with them in 2 ways. The first is like the swipe up or swipe down to set increments, or to double tap and hold, and where you get the fine grain experience. So the swipe up and down actions are the same pattern as the accessibility actions you saw earlier with swipe to delete. And double tap and hold gestures should work out of the box with the role, accessible role adjustable. The gesture can be a little bit hard to get the first time, so I like to think of it more as like a single quick clap and then a hold tap, where you can then drag your finger along the screen. The next one is, gestures, is an escape gesture. And this is when screen readers can use for dismissal of modals or sheets or overlays. In iOS, that's a 2-finger Z motion. On Android, that's a 1-finger J motion. And for Android, it's built in automatically, so you can use this as a back action actually throughout an Android device. However, on iOS, you will need to set up this prop for it to work. My last point I want to discuss is toasts. So they are everywhere, but they're also silently one of the more inaccessible patterns in modern apps. And it's mainly from 3 problems. The first, they auto-dismiss, so often before someone can finish reading them. Whoops. Going too fast. The second, they often are often outside the accessibility tree, so especially when they're rendered in a portal or a modal. or an overlay. And third, once they're gone, they're gone. There's usually no way to bring them back. So toast can be really frustrating if you're a sighted user who blinks, if you are a magnification user who's looking somewhere else, or if you're a screen reader user whose announcements are getting cut off. And GitHub even announced that they were deprecating this entirely, citing 2 WCAG or WCAG violations, and their replacement is Banner for page level and Flash for inline. Now, I'm not telling you to delete every toast in your app. Where information is redundant or the information is just secondary, it's perfectly fine. But the next time you reach for one, or I want you to ask yourself, if a user was to look away with this information, would that matter? If yes, use a banner, maybe inline feedback or a notification surface. If no, a toast is probably fine. Yeah. So if there's one thing I want to leave you with, it's this. Your animations were added there in your app for a reason. It can guide attention, it can communicate state, it can confirm feedback, it can make the interaction feel alive. So accessibility shouldn't be shutting them out. It should be making sure that everyone gets the message. Now, before you ship, ask yourself 4 questions. Does it move? Handle reduced motion. Does it appear or disappear? Make sure the screen reader is aware. Does it require a gesture? Provide an accessible action. And does it auto-dismiss? Maybe reconsider if needed. 4 questions, and they aren't going to catch everything, but they should catch most things. So thank you so much. I do have a QR code with a bit of a cheat sheet on there. It's got everything I've talked about and more, so with including examples, so that you can make sure that your apps are also accessible. And feel free to find me and tell me about your animation that you want to make accessible too, and hopefully I can help you.